All right, we're looking at problem 3 on page 453 of your geometry part 2 textbook. This is lesson 7.3, problem 3. One of the biggest problems that most students have is improving triangles, or doing what we call a formal proof, which is what this problem is all about. Now, in every proof, you're going to be given a certain amount of things, and then from those things, you're going to have to use ideas or definitions or things that you know from the past to help you to be able to understand how to prove whatever it is you're trying to prove. Now, when it comes to proving triangles similar, there's three main ways. You have angle-angle, you have side-angle-side similarity postulate, and you have side-side-side. So if you can prove all three sides of one are similar to all three sides of another, then that could work as well. So let's look at the problem here. You're given that FG is congruent to GH, you're given that JK is congruent to KL, and you're given that angle F is congruent to angle J. And you're asked to find if the left triangle is similar to the right triangle. Now, we would need well, let's just go through the proof. Statement 1, of course, you always start with your given. So they're listing that FG is congruent to GH and JK is congruent to KL, which, as you can see right here, is given. Triangle FGH is isosceles, and that comes from the definition of isosceles, the same way that JKL is isosceles, because when these two angles here, in either one of them, are the same, that's the definition of isosceles. And remember, for a proof, you have to have a reason for why you do everything you do in the problem. Then, of course, we go back to angle F is congruent to angle H, which are these two up here, in the same way that J is congruent to L, which are these two up here, because, again, based on the definition of isosceles triangle, we also know that the base angles of an isosceles triangle are always going to be congruent. So that's what allowed us to make this statement right here. Then, again, another given was that angle F is congruent to angle J. That was given in the original problem, so all we have to use for our reason there is given. Then for number 5, we know that angle H is congruent to angle J. That's called the transitive property. Again, you can think of that as the substitution property. Because if F is congruent to H, then that means wherever F is, I can put in H, and that's why that H comes about here. Same way in 6. The reason we can say that angle H is congruent to angle L is because we said here that H and J are congruent, so I can move H to right here, and therefore I can say that angle H is congruent to angle L. And so because of that, if I can go up here and mark this, because of that, I prove that these two are also congruent to each other. So angle F and angle H is congruent to angle J and angle L in the other one. And because of that, that means that those two triangles can be proven congruent to each other. So I write a congruency statement here. And the reason I can say that is because one of the reasons in this particular chapter is if two angles of one triangle are congruent to two angles of another, that's enough to prove that the two triangles, period, are going to be similar to each other. All right? So let's move down. And let me extend the page here a little bit. We're going to do our own proof in the got it section. Now, you can see in the picture there that you have two triangles that are kind of crisscrossing and sharing a common point B there. But they're telling you, these little arrows here, right here and right here, are telling you that the two lines are parallel, which is what this statement is saying here, given that MP is parallel to AC. Now, from that, again, if we're going to do a formal proof, we make our little crosshatch thing down through here. And of course, our statements will be here, and our reasons are always going to be over here. So let's start with statement number one. Let's always write, a good place to always start, or at least I tell my students, a good place to always start is with what was given. Okay, so the MP is parallel to AC. Now, because of other things that we've learned in geometry, because I know that those two lines are parallel, I also know that angle A is going to be congruent to angle P, because AP right here is acting like a transversal between two parallel lines. Okay, so I can say that angle A is going to be congruent to angle P. And again, the reason I can say that is a rule called alternate interior angles. Okay, of two parallel lines are congruent. So angle A is going to be congruent to angle P. Also, in looking at the picture for statement number 3, I could also say that angle B is congruent to angle B. An angle, mathematically, is always congruent, or these, and the reason those two, the angle B on the left side and the angle B on the right side, the reason those are congruent is because vertical angles are always congruent. That's another rule that we learned in geometry already. So because of that, you can also see here that I have two angles of one triangle matching two angles of another triangle. And so for the same reason as was in the example, and they don't all have to be this way, you could prove there are two other ways, side, 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 and side, angle, side. But I can say that triangle ABC is similar to triangle PBM. And the reason I can say that is because there is a rule in this chapter itself that says angle-angle similarity postulate. That if I can prove two angles of one matching two angles of another, that's enough to prove that the triangles are similar to each other. Okay. Now, B part says, for the figure in the right, suppose that you were given only that CA. So let me erase what I have here so that we can see this again. In B, it said if I could only assume that CA was similar to PM. Now, I'm going to put tick marks here only because that doesn't, I don't want you to understand that those are equal to each other. They're just proportional to each other, but it's so that I can mark it so that we can see what we're talking about. In the same way that CB is going to be proportional to MB, so I'm going to put two tick marks there and two tick marks there to kind of denote that. Could you prove that the two triangles are similar? And the answer is, even if I did know that, like before, that angle was congruent to that angle. Now remember, on B, we're not assuming that they're parallel. It's saying if the only thing that you were given was that those two sides were proportional. And again, just from before, vertical angles are always proportional to each other, or congruent to each other. That is not enough to prove. Now, if the angle had been between them, like angle C or angle M, because that's between the two sides that are proportional, we could have proved by side, angle, side. But the only angle we know is B, and the B is not between the two proportional sides that we've been given. I know that might sound a little confusing, but you know, that means that we don't have enough information, as well as you know, we knew that this was proportional to this and this one was going to be proportional to this one, But to find side, we would also have to prove that that one is proportional to that one. And again, that was not given, and that was not anything that we could deduct from that. So because we can't, the answer is simply no. Okay. And the reason is we just don't have enough information using the postulates that we've been given to be able to prove.